Alrighty, part 3 of lesson 6. Make sure you got your packets ready. And this lesson, we're going to talk a bit about the oil. We're going to talk about propeller systems and electrical systems. Once again, these are engine-related systems. There's other systems to cover, and when it comes to you know altimeters and all those things as well. Now that'll actually be in a future lesson. So let's talk about the oil system. This basically keeps the parts running smoothly within an engine. It lubricates is the first thing that oil does. You should know. It cools and heats both. It warms up and softens to allow the free movement of components, but it also regulates heat by absorbing the energy of generated friction. There's a little oil gauge there. That's a digital one. It seals. Due to its high viscosity, oil builds up in gaps. So you can get these gaps all around different parts of the engine, seals and things, and they get a little cracked over time, get hot and cold, or just aged. So the oil can actually seep into there and help fill in those gaps as well. Two types of systems. There's a wet sump and a dry sump system. The one in the 172 that we've been talking about is a wet sump type system. And it cleans, it traps the contaminants in the engine. And so when you change your oil, you're also cleaning your engine. When you change your oil, you're also cleaning your engine. This is what oil looks like when it comes out of an engine. This one blew a line or something happened here and it just ran all over the plane. Obviously, this is not what you want, but there you go. You can see all that dirt and everything that's been collected from the inside of the engine and put in there. One question that I find that examiners like to ask on your FAA, like practical test during your oral exam, is they love to ask you about, is your plane a wet sump or a dry sump system? So let's just go over that so you kind of know the difference in those two. The first one is wet sump. The oil stays in the engine and circulates internally. This is the most common system for most light airplanes. With a dry sump system, oil is in a separate tank and is pulled in using an oil pump. So make sure you write those two things down. And oil pressure gauges are required for all general aviation aircraft. It's one of the things that's required to be in every single airplane that has an engine. And so here's an oil pressure gauge on one side and an oil temperature gauge on the other side, and both are required for general aviation civil aircraft in the United States. There's another type of oil pressure gauge. There's an oil pressure gauge. There's an oil pressure gauge. This one you can actually turn between pressure and temperature. This is a temperature and pressure gauge, etc. So we'll watch a video in class about that, and we'll talk about that stuff in class too. It's a little bit of just personal goals for you. Let's talk a little bit about engine cooling, how engines get cooled. We talked about oil systems that helps with cooling, but a lot of engines in general aviation are actually just air cooled. There's these big ports in the front that pull air in, and they use something called baffling to help move the air around the cylinders, and then there's some sort of exhaust for that hot air to exit the plane, and it just, as you're flying forward through the air, it's just forcing cooler air into there. 5 things you should know about engine cooling. Number 1, excessively high temps can cause loss of power, high oil use, and engine damage. Number 2, engine cowlings are designed to have airflow around the engine. Number 3, so this is intakes for this airplane. Okay, and it's bringing in, this plane looks like it's surprised that we took its picture, but really these are just ports that pull in air for cooling. Cooling is less effective during takeoff, landing, and climbing. We'll talk about that in a little bit. There's a picture on 2-36 in the Jeppesen textbook. But that's because if you think about it, when you're climbing out, you're kind of doing this, right? When you're in level flight, the air is coming straight in. So if you just crank it up a little bit, it's still coming in, but it's also coming across it a little bit more. There's just not as much airflow. So if you're climbing out and you're seeing your cylinder head temperature get high, or you see like an oil temperature get high or something like that, you can always lower that nose a little bit and climb. Maybe you don't climb quite as fast, but at least your engine is being taken care of, and you really want to baby your engines when you're flying. They'll just last you a lot longer. Cowl flaps are vents you can use to open and close underneath the engine. Not every plane has cowl flaps, but a lot do. But if you do have a cowl flap, you have some sort of lever inside the plane so you can open this bottom flap. So if you want to increase airflow, you've got it closed, let's say, and you're like, oh, it's getting a little warm. Instead of changing your pitch, you can reach over, grab a lever, pull it, and it drops that thing open, and then the air has a little bit, it's getting pulled out faster, so therefore it's pulling more air in faster. It just increases the airflow around the engine. That's what a cowl flap looks like for real. It's probably like a 180, Cessna 180 or something. Use the cylinder head temperature gauge to know if the air is circulating well. Not every plane has a CHT gauge, but if it does, you'll know if it's circulating well or not by looking at how hot that one's getting. Something like that. And this one's got an EGT. EG2 has more to do with mixture. CHT has to do with airflow around the engine. So this is external temperature. This is internal. If this gets hot, like this cylinder right here is getting hot, that's a mixture problem. You're a little too lean. You might want to enrich in that mixture a little bit. If this cylinder head temperature gets a little hot, you might want to lower your pitch or open your cowl flaps if you have them. Cylinder head temperature gauges look come in all different flavors and sizes, so just know which one works with your plane. All right, let's talk about that spinny thing on the front that makes a lot of noise. It's called a propeller. And propellers, or we call it the prop, provide thrust to move the airplane through the air. Propellers are a type of airfoil or a wing. So there's different types of props. There's a fixed pitch propeller. That's what is on most training airplanes. You can't control it. It's been formed a certain type of pitch, and it just stays that way no matter what. It can't be changed by the pilot. You have different types of fixed pitch props. You have a climb prop or a cruise prop, and a climb prop, it just helps you climb faster, but it's a little less efficient in cruise. A cruise prop, you can't quite climb as fast, but in cruise you get a lot more efficiency, so you kind of have to pick one or the other. I feel like a lot of training planes have climb props on them because in training you do a lot of this, takeoffs, landings, maneuvers, blah, 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 where other general aviation aircraft may have a cruise prop on it because they go up, level off, and they just fly from point A to point B, and then they don't take off and land near as much as training aircraft do. But that's just my own personal opinion. There may be actual facts out there that prove that's wrong. I have no idea. But it seems like a lot of the planes I've flown with in training have a climb prop, fixed pitch prop on them. They're simpler, fewer parts. I mean, it's just a piece of metal bolted to the crankshaft, and they're controlled by the throttle. And you use the tachometer to help control. Now we have a constant speed propeller or a variable speed prop. And they basically have a complicated system there, but they can be changed. You can actually change the pitch of this. See how that's changing there? And that can be changed so you can have both a climb prop and a cruise prop on one plane depending on how you want to set it. And they are more complex in terms of building. They're controlled by oil pressure in the hub. I'll explain that in class. Use throttle and the manifold pressure gauge. So now you're going to have two gauges to do that. And use the propeller control. Now we're talking about that blue knob from previously when I mentioned it. You use that and the RPM gauge to control the speed of the prop. So you actually use the blue knob for the RPM for the tachometer, and you use something called a manifold pressure gauge. That's what you use the throttle for on a constant speed prop. It sounds complicated. It's really not. After you fly it for a couple hours, you learn a couple of settings. It's really not that hard. Understanding how this thing works in here, now that's tricky. So that's why we're going to go over that in class. There's a little animation of it working. Alrighty. Hey, there's that blue knob right there. We have one of those on our simulators in our class currently as well. There's a cutaway. I'll explain this in class, like I said, but there's the governor, and you can see it's got all this apparatus for twisting the prop in flight. All right, let's talk about the electrical system. Electrical system always seems to be not widely understood by a lot of different pilots when I do oral exams. It's one that I had to study really hard as well. I think we understand mechanics really well, but for a lot of people, electricity just seems like magic. I'm not quite sure how it works and why it flows the way it does. It's not like water. It's this mysterious thing. But you do need to know some basics of an electrical system for your training airplane. So I'm just going to go over some of the kind of broad strokes of electrical systems now. So let's start with this. The electrical system provides electrical power to the equipment in the airplane. And what does it give power to? It gives power to radios, GPS, lights, navigation equipment, flaps. In some craft, you may have electrical flaps. Some may be mechanical. Landing gear for some aircraft. Autopilot, if you have one. But what does it not give power to? We've talked about this. There's one thing missing that uses electricity. It's a pretty big deal in our plane. It does not give power to the engine. The magnetos do that. So it doesn't give power to the spark plugs. Doesn't give power to the throttle, doesn't give power to propeller control, it Does in some aircraft the flaps are mechanical, not electric, right? So just keep that in mind. Just because something's electrical in the plane or seems like it uses electricity doesn't necessarily mean that it's using the electrical system. So you need to study your aircraft, your training aircraft. All right, let's talk about some major parts of most electrical systems. One is a battery. It provides a source of electrical power for starting the engine and a limited supply of electrical power for use in the event of the alternator or generator fails. Now, you may not know what an alternator is yet, but we're going to learn about it just in a few seconds here. But basically, most planes have a battery in it. It's what we use to start the plane, and it's what we use in case of a failure of part of the electrical system. There's the alternator. The alternator is engine driven, so as long as the engine's turning, the alternator can produce electricity. It's got right there, you see a little belt attached to kind of a flywheel that's going around the crankshaft. This is all right underneath the propeller crankshaft here. And as long as that thing is turning, the prop is turning this belt, which is turning the alternator, which is producing electrical power. We have a master switch in a lot of planes. The electrical system is turned on and off with a master switch. Now, this is called a split rocker switch because on one side we have an alternator on or off, and on the other side we have battery on and off. And so some of them you can actually turn the alternator off and keep the battery running in case you got some sort of problem with the alternator and you want to take it offline. Then we have this thing called a bus bar. It's used as a terminal in the aircraft. That means that's where the electricity terminates. It's where it goes. And then it's connected to the main system. And it uses different size circuit breakers or fuses to deliver certain amperages of power to different electrical equipment within the plane. This is a complicated one. This is basically the back end of some sort of large jet, maybe a CRJ or something, and they folded it down, and the bus bar is just hanging out back there. And then we have circuit breakers. These are these black little buttons that a lot of people see that think are just a ton of buttons, but really they just pop out if something's getting overloaded, and that way it protects the electrical equipment in the plane and stops fires from happening a lot of times before they start. Because if it's based on heat, if they get too hot, they pop out. That's what this one is in. Probably in some sort of like a Piper aircraft. Looks like maybe a Seminole or something like that. But yeah, there you go. Lots of circuit breakers, one for each piece of electrical equipment inside the plane. The more electrical equipment you have, the more circuit breakers you'll have. Most planes have an ammeter. Basically, it monitors the performance of the electrical system, and it shows if the alternator or generator is producing adequate power. So if the amperage is showing a positive, that means that it's charging the battery. If it's showing a negative, it means the battery is being drained. Typically, when you're in flight with a stable electrical system, it's just sitting right here at 0. This is a diagram of a basic electrical system. We'll go over this in class quite a bit. So just kind of take a look at it and look at some of these major parts like the alternator. See if you can find the battery on here. See if you can find the master switch, the magnetos, and the bus bars. We'll talk about this in class. Little video, we'll watch later. Hopefully it's not sad face then. Electrical system video. Write down those questions in the back of your packet, man. We just went over a lot of stuff. You probably have some questions. Hopefully we'll answer them before you get a chance to even ask them. That's my goal with teaching in class versus just doing like video at home kind of lessons. But yeah, so make sure you write down those questions in that packet. And then we'll do a bit of a review in class. I think that's everything. I think the rest of it, we're going to do a poster project. We're going to talk about our quiz, not our first quiz, but our quiz on this stuff and all those types of things in class. Thanks.